Okay, so we're going to go over chain rule. This is on page 158. All right, 58. All right, there you go. Okay, this is 2.4, the chain rule. All right, so whenever I think of chain rule, I think of that Russian doll where you combine like a smaller doll inside of this casing. All right, so why do I say that? Because you want to look for like multiple parentheses or brackets. So chain rule can be applied more than once. We're going to look at examples where we need to apply once, but eventually we're going to get to an example where we can have multiple chain rules in a problem. You think of it as like that Russian doll, like more parentheses you have, more brackets you have, you need to apply the chain rule more times, okay? So the formal definition is on page 159 on the top. Okay, so if you go to page 159, it says theorem 2.1. Do you see it? It says the chain rule. They give you like a different form. Like first one, it says dy over dx is equal to dy over du times du over dx. Now du is that extra variable part, which means like you're looking for extra parentheses. Okay? But instead of using this one, you can also use, it says, or you can also use d of dx. This is just a different form of chain rule. D of dx, f of g of x. I like this method because it shows you the brackets and parentheses. So you can see the multiple parentheses within each other. So this one says, if you take the derivative, you don't do anything to, you take the derivative of outside, you take the derivative to the outside, but you don't do anything to the inner parentheses, you leave it alone, times, you multiply by the inner parentheses, but you take the derivative of that. So this statement is basically saying this one as well, same thing, but I kind of like using this notation. This one shows clearly that you have different parts as different parentheses. They even have the third, like a notation for this. This is on the very bottom of your page, same page. If you go to the very bottom, it says y prime is same thing as a derivative, right? This is the shortest version or short version of the chain rule. F prime of u, okay, f prime of u times u prime. I like this because this one is quite short. So f prime means outside derivative, and the u is inside of the parentheses, so u prime. Right, so I'll be using this most of the time. Okay? And I like this because I get to see it say fu and f prime of u without getting in trouble. So, right? Well, don't make sure you don't say it to me. All right?
Okay. We're on the same.
All right. So let's go to example 3 on page 160. This is example 3. All right, it says you want to find dy over dx. All right, so this notation is just telling you to find the derivative, right? Dy over dx is a derivative. And we have y is equal to parentheses x squared plus 1 to the third power. Okay. So I can use other rules. I don't have to use chain rule. All right. Remember I told you that in this class you want to find the shortcut. And sometimes you can see the shortcuts. There are cases where you don't see the shortcut. You might have to just solve this the long way. Long way will be actually taking this and FOIL. Right? So can you imagine if you take x squared plus 1 times x squared plus 1 times x squared plus 1? Do you think it's possible to FOIL that? I'm sure we can, right? And then we'll make it into this long polynomial, right? And then you take the derivative of each part, and we're done. You can solve it that way. But chain rule will be a shortcut to this. Do you see this parentheses? So the chain rule says, what is outside? You want to take the derivative of that is outside. So when you look at this function, what is outside? 3 is outside of the parentheses. So you're using the power rule. So you think of this as like a circle to the third power. What will be the derivative of something to the third power? 3 parentheses or circle x squared plus 1, because you don't do anything to inside, you leave it alone. And then you lose a power because you're using the power rule. So this is 3 times that to the second power, times, chain rule says times the derivative of the parentheses, right? So here's the parentheses, x squared plus 1, which is that prime. So this is y prime is equal to 3 times x squared plus 1 squared times the derivative of that will be 2x. And then we're done. We just need to simplify this. So y prime is 6x times. All right, there it is. All right, I'll give you time to copy that. Go ahead and copy those steps. Okay, I also like leaving my answer in this form. This is a factor form, so it's easier to set it equal to 0 and solve for x variables. So I kind of like using the chain rule. I think this was a fairly easy example to follow. Okay, of course, in this case, we could have used foiling method to actually foil this and then use the power rule. But there are some cases where you can't really foil. And only method you can use is the chain rule. So let's take a look at that example. For that one, we're looking at page 161. All right, example 5. Find example 5. It says f of x is equal to cubic root of x squared minus 1 to the second power. Okay, we cannot FOIL this because this is a cubic root or square root. Alright, so previously we learned how to rewrite this format. Like if you have square roots or cubic root, we learned how to rewrite this as a power. Do you guys remember how to rewrite this?
Yes.
How would you rewrite this? This is f of x is equal to x squared minus 1 to the power of 2 over 3 is correct. Alright, but if you read the direction on the top, part A says you want to find f prime of x is equal to 0. Part B says where f prime of x does not exist. Now, does not exist is similar to undefined. Alright, those are the two things we need to look for. Alright, so let's go back to our chain rule. Alright, let's go back to our chain rule. I want you to think about the chain rule formula. Let's see if we can apply that here. So try to help me. What is f prime of x? Again, what is outside of the parentheses? 2/3 parentheses x squared minus 1 to the power of negative 1/3. And what is inside of the parentheses? X squared minus 1 prime. So this is f prime of x is equal to 2/3 times x squared minus 1 to the negative 1/3. And the derivative of this will be 2x. Okay, now we started with this notation, this form, right? Do you see this? We changed it to something that, we changed it to a form that where we can use the power rule. Once we use the power rule and the chain rule, you want to put this back into this format. So can you simplify this so that we can change it into that format? What do I do with that negative exponent? Yeah, don't you have to put it on the bottom? So x squared minus 1, 1/3. And then this is 2 times 2x, isn't that 4x? And this is a third, so you put 3. I hope you guys follow what I just did. And we don't leave it as x squared minus 1 to the 1/3 power. How do I change this 1/3 power? Cubic root. Very good. This is cubic root of x squared minus 1. Okay, this is it. This is my derivative. But we're not done. What does it say? Right here. Part A says we need to find f prime of x is equal to 0. So what is this notation asking you to do? You don't plug in. It says set the derivative equal to 0. So what's my derivative? 4x over 3 cubic root of x squared minus 1 is equal to 0. How do I solve that? Alright, do you guys remember cross multiplication with proportion? You have to cross multiply whenever you have proportion, fraction equaling to a fraction. How many of you guys remember cross multiplication? Alright, so what is it when you cross multiply to 0? What is 0 times anything?
0.
So what do we get then? This is 4x is equal to 0. So what is x equal to?
0.
Alright, so when x is equal to 0, your derivative will be equal to 0. But what is this derivative? Like, what's another word for derivative? Do you guys remember? Slope. That's your slope, tangent slope. It's saying your tangent slope is 0. So if you have a slope of 0, what type of line is that? Do you guys remember? This is a horizontal line. You're going to have a horizontal tangent line at x is equal to 0. Let's see if that is true later on, okay? Alright, let's go to part B. It says f prime of x is equal to d and e. Alright, what is another word for d and e? I said that is same thing as undefined. So they're saying, how do we get 4x over 3 cubic root of x squared minus 1? How do we get to that to be undefined? Or d and e? D and e does not exist. How do I get to undefined? What do I need to have? You need to have a 0 in the denominator. You need to have a 0 in the denominator. Does that make sense? So I don't have to set everything equal to 0. I just need to set just 3 cubic root of x squared minus 1, which is your denominator, equal to 0. That's it. That's all you need to do. So let's go ahead and solve this. You divide both sides by 3 and 3. What is it? Isn't that cubic root of x squared minus 1 is equal to 0 still? How do I get rid of this cubic root? you cube both sides. So if you cube both sides, 3 will go away. You have x squared minus 1 is equal to 0 to the third power is 0. You add 1 and add 1. X is equal to plus and minus 1. So it is undefined when x is equal to 1 and negative 1. Alright, so let's see. Let's take out your graphing calculator because we have never seen anything like this before. Never. Alright, so let's go ahead and take out your graphing calculator. If you need to borrow my graphing calculator, go ahead and learn how to graph this. Alright, go ahead and graph that function using your graphing calculator. Alright, so I hope you know how to use your graphing calculator. So how do you find cubic root? Go to math. And then this is x squared minus 1 and square. Okay, is this what you have? And then if you graph this, alright, you can zoom in a little bit if you want to. Let's go ahead and zoom in. Go to zoom. And zoom in. Alright, let's see if our answer makes sense. Alright, do you remember it says part A says your slope is 0 and x is equal to 0? Isn't x equal to 0? Looks like here it is right there. Do you see that hump? Does it look like we have a horizontal tangent line?
Yeah.
Right there? So doesn't it look like we have a horizontal tangent line at 0? Right? Okay, this one is at positive 1, and this one is at negative 1. Okay, what happened when this was undefined? Remember, it was undefined at 1 and negative 1. Wasn't the part B it says undefined at positive 1 and negative 1? Doesn't this look really weird? Have you seen graphs like this? Right? You have never seen any graphs like this up to this point. We're going to see a lot of these things. Do you see this sharp turn? Do you see how this is turning really sharply like that? This one has a special name. We don't call it a sharp turn. We call it cusp. We're going to call it cusp. Okay? So, I want you to think of 3 things. When you see the word undefined, I'm going to write it down here, okay? When you see the word undefined, I want you to think of 3 things. It could turn out to be cusp, which is a sharp turn. It could turn, which it did right here, right? This is an example of cusp. Or it could be open circle. You know how sometimes we have this open circle on the graph? Or it could be a vertical asymptote line. VA, vertical asymptote line. You know how sometimes you have function going up and down like this and you have a vertical asymptote line? So if it goes up and down like that. So whenever you have undefined or does not exist, I want you to think of three things again: cusp, open circle, or vertical asymptote line. And we'll be using that in chapter 3. Okay? All right, I'll give you a little bit more time to kind of copy that down. All right, our next example will be using multiple chain rules. So we're going to apply chain rules multiple times. Okay, for that one, we turn to page 163. This is example 12. It says f of t is equal to sine cube for t. Now again, it could be any variables. It doesn't have to be t, but usually we use t for time, t per second, or something like that. Alright, usually trig functions are written this way, but if you want to use chain rule, you need to learn how to use parentheses around some parts of this trig function. So you want to rewrite this. I'm going to rewrite this as f of t as parentheses sine parentheses 4t to the third power. I hope you can see that this should be written this way. It's the same thing. Already I'm thinking in using multiple chain rules. Why am I thinking of using multiple chain rules? Because I see multiple parentheses. Do you see that? Alright, so tell me what is outside. Let's go back to chain rule again. Alright, go back to your chain rule formula. So what is outside of the parentheses? 3. So what's the derivative of that? 3 parentheses, sine, you don't change anything, you leave it alone, to the power of 2 times parentheses sine 4t prime. Take the derivative of inside. I want you to use prime, and I want you to take derivative as the next step. Alright, this is where I use the chain rule. Do you see the chain rule? I used it. But you're going to see a chain rule again. This is our second chain rule. So f prime of t is 3 times sine 4t squared times. How do I take the derivative of this? So what is outside? No, we don't look at 1 within the parentheses. What is outside? Sine. Sine is outside. So what's the derivative of sine? Cosine, you don't do anything to inside, which is 4t, times what prime? Do you see this inner parenthesis right here? Inner parenthesis, so it should be 4t prime. Alright, how many of you guys see what I just did? Alright, that's not good. We need to practice. Alright, so again, there's an extra parentheses inside. We need to take the derivative of that. Alright, so if I simplify this, this is 3 sine 4t squared times cosine 4t times derivative of that will give you 4. Okay, so you want to organize this again. You want to go back to this form. So how do I rewrite this as this form? And we have 4 times 3. That will give you 12. 4 times 3, 3 times 4, 12. This is sine squared 4t times cosine 4t. That's your derivative. Alright, let's do a similar example of this. Alright, let's see if you guys can do this on your own. So let's practice one out of your textbook. Homework page 168. Find number 61. Number 61. Alright, first rewrite this. Okay, I hope you guys rewrote this as f theta 1/4 parentheses sine parentheses 2 theta squared. Okay, how many of you guys have that? Okay, that's where you need to start. So if you don't have that, make sure you start from there. Okay, so can you guys help me with our derivative? What's outside? What's outside? 2. So what is it? 2/4 times sine 2 theta to the power of 1 times parentheses sine 2 theta prime. Okay, how many of you guys got that as a first step? Okay, not bad. Is equal to 1/2 because 2/4 is 1/2, right? Sine 2 theta times what is outside of this? Isn't it sine? So what is that? Cosine 2 theta times parentheses 2 theta prime. So what is 2 theta prime? 2, and this 2.5 goes away. So your answer is sine 2 theta times cosine 2 theta. That should be it. How many of you guys got that one? Alright, good job. That's multiple chain rule. Now, we only used it twice here. Do you understand what I mean by using chain rule twice in this example? You can have an example where you need to use 3 times. Alright? There are some cases you might have to use 4 times. So just be careful. Alright, so in every section, we usually go over about 3 to 4 new rules. Like remember 2.1, we went over constant rule, like it was 2.2, wasn't it? 2.2, we went over constant rule, and then power rule, and 2.3, we went over product rule, quotient rule, and some other rules. Alright, so how many rules have we covered in this lesson? 1. Which one? Chain rule. We just went over chain rule. But of course, we're going to have other rules. Okay, we need to add other rules. Okay, it's not just chain rule, we have other rules. So for the other rules, we turn to page 164. Page 164. Alright, page 164, you're not going to write all the rules because they're giving you like a same thing but with different versions. I'm going to tell you which one to write. On page 164, this one is the natural log rule. Okay, do you see it? It's natural log rule. You just need to write number 2. And not the whole thing. You just need to write d over dx ln u is u prime over u. This is it. So whatever you have here, it could be any variable. It doesn't have to be u. It could be x. Whatever you have here, it is that prime over u. Whatever you have there. Okay, this is the second rule that we need to learn for today. We have other rules. Okay, for the other rules, we have 2 more. We turn to page 166. Go to the bottom. You're going to find a box with 1, 2, 3, 4. You have other rules on the top. It's basically one of those 1, 2, 3, 4. Okay? So I'm not going to have you copy down all the boxes. So on page 166, you just need number 2, which is the exponential rule. This is d over dx, a to the power of u. All right, do you see the exponential rule? Do you see that exponent? It is ln a times a to the u times u prime. du over dx is u prime. Okay? So whatever you have there, are there. And the last rule for today, number 4, right underneath that, this is any log base rule. This is d over dx log any base a u is equal to 1 over ln a times u prime. Okay, so I'll give you time to copy these 3 rules. So far today we have learned a total of 4 new rules. So if you count up all the rules we've learned up to this point, do you know how many rules we have learned up to this point? No, not that many. Go to page 167. Do you see that large box? Those are all the rules that we have learned up to this point. Out of all of those things, how many of them have you memorized? Which ones do you know? You need to memorize all of them. Okay? Alright. Okay, look back, look at me. Look at me. Okay, do you see this textbook right here? Go to the very front page, behind the front cover right here. You see it? Alright, and then next to it, it says this. You see it on the very top, derivative and integrals? Do you see all the derivative rules on the top? 24 of them? For this class, we need to memorize all 24 of them. And then do you see the integral formula, which we're going to cover in chapter 4? Do you see those 20 formulas? We need to memorize all these 20 formulas. So we have a total of 44 formulas we need to memorize before your AP exam. Alright? You think you can do it? You have to. You must. I'll force you to memorize all of them. Alright? We're going to have daily quiz on those formulas during second semester. Every day you come in, we're going to take a test. Every day. You come in, here it is, you take it. You come in, here it is, you take it. So you get 100%. And if you miss one, you get a 0. I'm not kidding. Okay? And then at the end, you're going to memorize it, and you're going to say, okay, I know this. And you're going to get 100% all the time, and you will thank me because you get 100%, right? Okay. All right, let's try one of these rules, okay? So for this rule, let's turn to page 169, number 123. Page 169. So page 169, number 123. Page 120, I'm sorry, 169, number 123, it says y is equal to 4 minus x squared minus ln parentheses 1/2 x plus 1. And then we have a point at 0, 4. All right, read the direction. What does it say? What do you want to find? We need to find the equation of a tangent line. Okay, isn't it similar? Every section we cover, don't you have to find the slope, derivative, and the equation of tangent line? We're coming back to similar questions over and over again. All right, so I think it's easy to take the derivative of 4. That's easy. I think it's easy to take the derivative of x squared. I hope you guys know. This is the only new part. Go back to ln formula and see if you can apply that formula to this one. All right, go ahead and try it. I'll give you about 30 seconds, okay? You think of this parenthesis as u. This whole parenthesis as the letter u. Right? So what's the derivative of 4? 0. What's the derivative of x squared? So it's negative 2x minus, what's the derivative of ln parentheses? Isn't it 1/2 x plus 1 prime over 1/2 x plus 1? All right, how many of you guys got that? What's the derivative of 1/2 x plus 1? Isn't that easy? Negative 2x is equal to minus 1/2. Isn't it just 1/2 over 1/2 x plus 1? It looked very difficult, but it turned out to be a pretty easy problem. Do you see it? Okay, now, this is your derivative. I can simplify this, but I don't think I really need to. How do I find the equation of tangent line? What do I need to have? I need to have the formula. This is it. So I need to find the slope. How do I find the slope? Plug it in. What do you plug in? what do you plug in? 0. You plug in 0 for x, so plug in 0 and 0. Go ahead and calculate that and tell me what you get. Oh, come on, guys. You don't get a 0. Negative what? Half. You get negative half. Because this is 0, this is 0, this is negative half over 1. Negative half over 1 is negative half. This is your slope. We're not done. How do you find the equation of the line? What do we need to use? Point slope, which is y minus y1 is equal to m times x minus x1. All right, so help me plug this in. What is it? Y minus 4 is equal to negative 1/2 parentheses x minus 0. All right, simplify this and tell me what you get. What is that? Y is equal to negative 1/2 x plus 4. Here it is. This is representing what? Tangent line. Tangent line. So read part B. What does part B say? Okay, so let's take out your graphing calculator. Let's go ahead and take out your graphing calculator. You have it with you? Yeah, if you need to borrow my calculator, go ahead and borrow my calculator, but have your calculator with you. I want you to follow the directions and make sure you do part B and C. Why do I want you to do part B and C for your homework? So that you can practice. You need to practice. Practice using your calculator. So let's put 4 minus x squared minus ln parentheses math to get fraction 1 over 2 x plus 1 close the parentheses. And then what are you going to put as your second equation? Your tangent equation. Your tangent equation, which is negative math fraction 1/2 and then x plus 4 and then graph. Oh, my window is no good. What happened? What did I do before? I zoomed in, so what do I need to do? Zoom out, zoom standard, zoom out, yeah, zoom standard. All right, let's go to zoom standard. That's neat. Look at that. And look at that. All right, does your graph make sense with this particular problem? Why? Because we have a tangent line at where? 0, 4. We have a tangent line at 0, 4. There it is. All right, so I want you to practice. Okay, that's it for lesson today. We'll spend an additional day tomorrow. Okay? If you have any questions, you can ask me tomorrow.